Hello friends, welcome to Fox Tech. So today we're going to see another topic from the Kubernetes autoscaling. So it's called Horizontal Pod Autoscaler. So hope you've seen our last video which we explained about what is Kubernetes autoscaling and what are the method it uses and what is the advantage about it. And this is a continuation from that. So in that we're going to see particularly Horizontal Pods Autoscaler. So what is horizontal pod autoscaler? So you can see in the name itself, it says like it scales the pods horizontally, right? So you can say in the diagram, so you can say there is a single pod at this moment before HPA is auto scaling. And after we enable the HPA, you can see the pods are getting increased more than one, right? So HPA is one of the best and most used autoscaler, we can say. Again, it depends on the usage and based on your use cases, right? So you should plan your microservice architecture as per your autoscaling requirement, and based on that you can enable with whatever the autoscaling is required, right? So this horizontal autoscaler is like type of the autoscaler which can increase or decrease the pods from your deployment or replication controller or stateful set, even replica set. Okay, so it by default it was started with the CPU utilization. Then they have improvised a lot in the second versions, and from that they have exponentially expanded multiple matrices. Okay, we're gonna see that and in the explanation, but it's just a hints about it, right? So before we jump into that, so we should understand about a couple of things like how the HPA works, right? So that's one thing we should always understand to troubleshoot, or any kind of a basic understanding is needed. So that will help us to give more clear picture about any kind of a technology or the tool, right? So again, so one, as we said, the horizontal pod scaler, how it scales or scale out, and this uses from the matrices. The matrices are called as like a CPU matrix or memory matrix or any kind of a customized matrix, whatever you are defining. Based on that, it changes the number of replicas, and how it changes, it's keep check your pod utilizations and how much the pod is utilizing and how much memory is using, how much CPU is using, whatever the metrics you given, it's keep monitor that. And if there is the thing is made the threshold, immediately this HPA is taken action, like it decides, okay, now there is a high number of CPU request or there is a high number of memory request. If you define like if there is a memory or CPU, you have to increase the number of pods. When you define in the HPA file, this will take that number. Okay, there is a threshold is met and it's wait for certain time, and then it scales your pods. It scales one by one, or number of pods, whatever it's required, immediately it picks up. Or based on the CPU or memory utilization, it scales number of pods required for the averaging that. Okay, so let's understand how this works by understanding the flow. The first thing is you need a metric server, which if you know about a metric server is providing provides all the metrics utilization for your Kubernetes cluster. It deploys on a kube system namespace, and from that it will keep monitor all your pods matrices and it's keep it stored. And if any service required, so from there you can pull it and you can visualize it, right? So again, the HPA is reading from the metric server. It checks the metrics, and also it compares with your how much CPU you defined, how much memory you defined. It will just check it on the loop, and then if there is anything is identified, like there is a high spike on the CPU or memory, immediately it's trigger the scaling up on your deployment or any stateful set or replica controller. So let's say like you are running with a single pod and there is high utilization, immediately it triggers another pod to be launched. Again, it loops, it's every 30 seconds, it checks, And then, so if there is a spike and there is a more number of pod is required, immediately it triggers another pod. Okay, so these are the steps it runs on the autoscaler, horizontal pod autoscaler, and this is how it works. Okay, and you can ask what are the metrics it supports. So, or from where the metrics are pulled, or what kind of metric it's used. So it supports 4 metrics. One is from the resources. The resources nothing but the CPU or memory, whatever we are defining, and our pod or deployment, the limits or request you set, right? So memory, CPUs, and also it supports object matrices. Object matrix is nothing but, let's say, like a ingress, right? Your ingress is getting a number of hits. So even it tracks how many hits it's reaching to the ingress. Based on that also, you can scale it or scale out your pods. And pod matrices, especially the pod matrices, again, it comes from the request and resource. But other word, we can say it like a other word, we can say it like it's a pod metric source, and information is running on the runtime, and it collects all the collected in the Kubernetes. Again, it's coming from the metric server, and it's process the transition processed per second. Also, it's check. Let's say like my pod has to be run like a 10,000 transaction only. So even that can be tracked using this. Okay, so you can track that, but make sure that if you are running a single pod, the transaction will be calculated in single pod. But if you are running a more than a one pod, it takes the average of the values. Okay, so you should calculate the average, and you should define your number of thresholds based on that. Okay, and also it checks external matrices. The external matrices can be like you can say like some Prometheus queries, or you can say like a load balancer. From the load balancer, there is a number of it is high, so you have to scale it up, right? Even that matrix also can be pulled from the pulled, and you can scale it using the horizontal pod scaler. Okay, so this is how you may need to define your horizontal pod scaler. You can see in the kind, it's mentioned like horizontal pod scaler, that is the kind it's used. And we are taking an example of one application. This is a version 1. Please note these versions. We're going to speak about it. And you can see in the version 1, we were able to just track the CPU matrices. Okay, so what it's defined here, you can see the version is API 1, autoscaling version 1, and kind is pods autoscaler, and metadata for your deployment name, just for your understanding. And the spec, here it's a main thing. So what is a target, right? So I'm going to say my application version 1, please specify whatever the application version you have, and which kind you want to go for, the deployment or replication controller or stateful set. You need to define it properly, and what is the name of the resources. Okay, so my resource name is HPA demo deployment. So I'm just giving you my pod name here. Okay, so your deployment name should be validated here. And what I'm telling, minimum there should be a 1 replica, obviously. There should be a maximum number of replicas, let's say 10. Okay, I'm just putting as a 10. So you, based on your requirement, you can change the number. On what basis the scaling should happen? Target CPU utilization percentage should be 50%. If it crosses 50%, it's wait for 30 seconds. Okay, there is a high spike. Immediately it scales your pods. Okay, let's say like how the scale down will happen. So again, there will be a, let's say like it's created 3 pods. It take an average of all 3 pods should come below the 50. Then it's automatically scale it down. But please be noted, it takes a time. We're going to see it in the demo. I'm not going to explain much over here, but we're going to see that again, right? Next. So now we've seen about CPU. The next thing is memory is the one you should consider, because memory is the one most of our applications are utilizing currently. If you see most of the Java application or something you take, so it's all like a memory intensive applications, right? So that's how the memory also we have to track, but it was not part of auto scaling version 1. It scaled from the V2 beta versions, and now we are having a V2 finalized version, and in that we have these facilities. Again, you can see in the auto scaling v2, and with v1 the memory won't work, please be noted. And kind horizontal pod scaler and metadata. Again, I'm just giving like a version 2 memory as for my reference, and the spec. Okay, in this I'm gonna say like minimum replica should be 2 and maximum should goes to 10. Okay, and again I'm defining my test like a target, which version of the API that particular deployment is set and deployment, and what is the name of the deployment. Then I'm going for the metrics. The matrix is defining as following. The type is resource as the type. So as we've seen, there is a multiple types of matrices. So we should more specific on the type. From the type, it's check the resource. And what is the name? It's a memory and target. Okay. Type should be averaged value, and average value should be 50 million, 50 MB. Okay. So this should be defined as following. Otherwise, you may get an error if there is something on the syntax. So you should always carefully define it. Okay. So next. So we have seen there is a separately read CPU and memory, but there could be a possibility like some way you need to configure both. Some application may be utilizing a CPU high, sometimes the memory will go high. So, but I need to make sure both the way it should be work, right? So even HPA allows to define multiple matrices like this. So you can define the things. So you can define multiple matrices. So with like this, so you can see it here, I'm again defining, and multiple metrics are supported only in version 2. It won't work on the version 1. So again, you need to use just memory aspects. Similar ones still like this. You can define still this HPA test or name of the pod deployment. Below that, the metric starts. So from there, you can define what resource and what is the name and what is the utilization and how much utilization you are looking for. For CPU, it should be utilization, and memory, it should be averaged value. Okay. So please be noted, even memory with utilization, it won't work sometimes. So you should always carefully define it, and it's case sensitive. You should define the value properly. Okay. So this is how you should define it. And what are the other supported metrics? It can be, one is like a load balancer traffic. It supports even your load balancer traffic and outbound connections and queue depth and latency of the function or dependencies. You can even calculate the latencies and HTTP request throughputs and size of the message queue if you're using any kind of a message queue services like a RabbitMQ, and how much the request latency is coming up. Okay, so like that you can scale it up the matrices, and with that you can define your HPA configuration. Okay, let's see some sample demo here. So in the demo, what we're gonna do, so we're gonna deploy some test deployment, and also we're gonna deploy a service, and we're gonna see how how much CPU you're going to utilize, and from there we're gonna define like a multiple things, and we're gonna just deploy it and see the HPAs are getting created or not successfully. We are not going to demonstrate much, but we're going to demonstrate how the CPU utilization will be. If there is a high CPU utilization, how the traffic will be handled. Sorry, how the auto scaling will be handled. We're gonna see it. Okay, so let's start our demo. Let me log into my server first. So here I'm using AKS for my demo, and I'm running from my Linux box. So you can choose any kind of a cluster. It's up to you. It doesn't have a problem. And also please make sure if you are using any kind of a cluster, you should install the metric server first. Otherwise your cluster or this demo or HPA won't work. Okay. It's always recommended to have a metric server even for monitoring best services. So keep install it and use it. Okay. Okay. Let me move my window here. Okay. Let me go for my HPA test. This is the folder I have created. Already I have created the sample application with this Docker file. In this, what we did, we just took some PHP and we just installed some PHP file. This file will have some dummy code. So let me show my index.php also. This just for the load check. We are going to use this. We're going to run that load test anyway. So I will show you that in time. And let's start with our first HPA file. Let me show you the HPA file also. So this is a HPA file and we can see this. Okay. So before we start, what we're gonna do, so let's test it. What are the API versions we have, right? So how to test the API versions in kubectl with kubectl? Kubectl API versions grep. Let me pull only auto scaling. I don't want all the APIs. I'm gonna check only the auto scaling one. And you can see there is a 4 versions we have, but we are not going to use all 4 as it's just a beta versions. We're gonna use the standardized versions, V1 and V2, and V1 only for again CPUs, right? So as I said, the metric server is important. So how do you check the metric server is installed or not? So let's run a kubectl op command. It will, if you see the result, that means you have a metric server installed. Okay, so let me run for a node. And yes, you can see the response is coming up. It has a 3 node and there is one agent pool and 2 is a user pool. And this is the current CPU and current memory utilization, and this is a percentage of utilization, right? So let's check for a pod. I don't have any pod at this moment, but let me check. Do I have anything? I think my Argo CD may running here. Okay, so I have my Argo CD running on Argo CD namespace. I'm gonna get the top for the Argo CD namespace, and this is the utilization. You can see it's using a 1 millicore and also it's using a 26 millicore here, right? So this is good. So we can confirm like our metric server is installed and is running. In case if you are not installed or you are not getting this kind of a response, what you have to do, I will link my page. So there I have given the step how you can install the metric server. You can refer that. There is a 2 way you can install directly. You can use a kubectl and apply the config, or you can use Helm also for your test. Okay. So however, whatever the flexibility, you can use it. Okay. So let me pull the REST API call, sorry, Podmetrics API to output. So with this you can see what all the metrics as it provides. Okay. So this API will give you the from the metric server and only for the nodes you can specific here, and you can see that. Okay. So it will give you the metric list, and also you can see what is the timestamp, how much CPU and how much memory. Every details you can compare it. Okay. This is for the node. And if you like to see for your particular pod, okay. So let me see again, let me get the pods, and I'm gonna see it for, let's say, like a Argo CD server. Okay, so how to check only Argo CD pod. So this is the command kubectl raw and API metric server, and what is the version and which namespace. It's Argo CD namespace. And pods, which pod? I'm gonna check this pod, and then I'm gonna grab in the and this is the metrics. Okay, so you can keep run this, and this is what even the HPA does. It's keep loop and it collects all the metrics and run it, right? So this is the things happening in beyond, but it's not, we don't need to do it always and track it. So we are not going to do that as we have everything already. So we're going to directly jump into the demo. Okay, so let me do one thing. Let's create a deployment first. Okay, this is the HPA for deployment first. So this is the HPA deployment I have created for our test application, and this is a PHP application. what I did, this is my name of the deployment, and I have run everywhere HPA test. And also I given the image name as HPA test. Okay, you can feel free to download that image and rename to your comfortable, and you can use it. Okay, and I'm using it again, the name also I'm using HPA test, and the port I'm giving 80, and selector it should be HPA because I'm using a label as a run, so I'm just using that here. Okay, right. So let's test it with some sample namespace. What I'm going to do, I'm going to create a namespace for that. Create ns. I'm going to say HPA test as a namespace. I'm going to create. Okay. So now the namespace has been created. So what I'm going to do, kubectl apply -f HPA test, and I'm going to put it on -n and the particular namespace. Okay. This is how even you have to do it. Mostly we don't use it in the deploy default one. So that's what I'm just putting it everything on the selected namespace. So for the best practice, let's check that kubectl get all. I'm gonna run all to get from the HPA test namespace. Well, so we have a pod running already, and also we have a service whatever we created, and deployment also ready, and replica set has been kept 1. Okay, why 1? So we have defined it in this as 1, right? Right. So next, what we have to do? So we have to deploy our HPA. So let me open a HPA file what I have prepared already. So this is again, so HPA with V1 and autoscaler, and I'm just naming it as it is, and I'm just going to change it. Okay, we have to change it as per this, right? So HPA test is our deployment name. So I'm gonna change it to a deployment test, HPA test deployment, and I'm gonna say HPA. As it's a CPU, I'm gonna name it as CPU now, and one replica has 50. Okay. So now we have run this. So now again I'm gonna deploy it only on my namespace. Yes. Okay. So how do you check the HPA is ready? So I'm gonna say again HPA. So you can see it's currently ready, but it's still in unknown state because there is no metrics has been pulled. It's taken 30 seconds, as I said. So after 30 seconds, you can see it started pulling a matrix. Still it's in a 0 because we are not putting any kind of a load, minimum pod and maximum pod, and we don't have any replicas, only one replica at this moment, right? So far we are good in this. So what we're gonna do it now, we're gonna generate some load. Okay, so for our service, let me have a command ready here. Okay, so let's run like a kubectl -n HPA test, and I'm running a load generator, and I'm using a busy box to generate. It never restarts, and while sleep 0.1 second, and this is what I'm doing. I'm creating a service for this one, so which is nothing but your HPA test, right? So what it's going to do, it's going to run it and going to give us okay for limit certainly. Quickly we'll take a duplicate screen of this, and the duplicate screen we're gonna see how much pod it's going to increase. So I'm going to run it and see that. You can see it here. There was a continuous request and it's keep checking the load, and also you can see the number of replica is increased. You can see previously there was only 144, and due to that it increased the number of pod to 2, and still we are hitting and this is keep on increasing. So you can see this number of pod will keep on increases. So let me open another screen to show you that number of replicas also. kubectl get pod-n hpa-test. You can see it here, there is a 3 pod running. Earlier we seen there is a 1, and there is a load generator also, it's running, keep on running. And let's run it for 1 more minute and we want to stop it. Okay, the load is not increasing very much, but the load is still on high. So you can see number of replicas still on high. But what we defined on our file, it should be 1 replicas, but it's going more than that, right? But let's stop it. So you can see as it's increasing, now it's increased to 6. To maintain the load, it's look like heavy, and you can see the number of replicas is just doubled it, right? So this is what it does, and let's not go beyond that, and I'm going to stop it. I'm going to stop the load, and there is no load now. And you can see the load will take some time to reduce. It won't be, that's another problem I can see myself, because it's not immediate effective, right? So it's keep an average value and it's try to reduce the number of pods. So at this moment you can see it's 89% and there is a number of replicas 6, but it takes little time, at least 2 to 3 minutes or 4 minutes to reduce it, because it's wait for some time to make sure there is no load is coming unexpectedly, and make sure that is under control. Okay, still you can see it's came below, but it's not reduced the replicas. Okay, let me pause it. When we come back, I think the number of pod will be reduced. Okay, all right, so you can see it now. It's took 10 minutes to scale down your number of pods, and we can see it now. It's back to 1 pod, right? So let's quickly confirm that with the pod command. Make sure we are not do, and I'm gonna check it number of pods. You can see there is only one is running and we are not restarting the load generator, right? So you can understand how it works, but the one more problem is it's taking a time to scale down, because it's monitors and it's make sure there is no more hit is coming. So then only it's reducing the number of pods. Okay, so it's a better always, again say, by when we are focusing on the cost, either running the 6 pod or without running running a pod for a whole night or whole day without any utilization, or our application is affected with some unexpected loads. So this number is not a much issue, right? Well, so hope this is helpful, guys. So let's quickly check our memory also. So how it's been created. So let's see that now using. So memory. So as I said, like this, you have to define it. We have seen already the file name. So I'm quickly going to just apply this on the namespace kubectl apply -f, and this is a file name. -n, I'm going to apply to the LPA test namespace. Okay, you can see there is some spelling mistake or something. Okay, I applied wrong file then. No. Let's check it. What we made a mistake. Average value. That's right. Okay, there was some typo. I'm sorry for that. And with that, we have defined it properly. And now we can check it. Let's see here. Get HPA-N HPA-test. And you can see there is a one for memory and one for CPU already we have. And there is another example what we seen, there is a multiple one. So how do you define the multiple one? So we're gonna see it here. So we'll make sure there is no typo. Okay, this is good and utilization is correct. And this is what we are doing. And we're gonna name it HPA V2. I wanna say HPA multi as a name. Okay, so let's save it and let's apply the file. Okay, so let's check this. Get HPA. And you can see there is a memory utilization is going on, and you can see the number of pod is getting increased because the memory is in use. And then, or we can say there is a minimum pod what we defined is 2, right? So that's how it's taken as a 2. If you increase to 1, it takes some time and it's revert this change. 1 and save it. And I'm going to play the change. Let's say the multiple one now. Okay, there is a minimum part and it's going to reduce to 1 shortly. And this is how we have to do it. You can see it's capturing multiple entries, right? And then one more thing, like if you want to have multiple things like this, you can keep add your file. And it's not recommended to have a 3 or 4 HPAs because there will be a problem. If you want to use combine, you use one file with all the entries. So as it's for a demo purpose, I have created multiple for same deployment, but it's not recommended. Okay. All right. Hope this demo is useful, guys. And now let's check about the back to presentation. And in this, we're gonna see what are the limitation on HPA. Okay, that's we should understand always because that's how we can plan to use the HPA, right? And what is the limitation? The first thing is like application architecture must support your distribution workload. Let's say like you have a pod or the application which capable to run only one pod. Okay, so in that case, you should not use horizontal pod scaler because that will destroy your application. How this situation may happen, right? Let's say like you are running some license application. Let's say you are running some licensed application and the license application can run given only for one pod. So on that time, obviously you can't run more than one. Then you say like a license is not working or something, right? Or your application connects with only one pod, or the database can support only one pod. That is not a case, but I'm just telling example. Like that, any dependency things are there. So you should make sure that is not the cause, and you should not use HPA for that, right? And then it cannot handle the spike unexpectedly. So let's say like you are having a new virtual machine and that is loading some that is just making any kind of high demand loads. HPA cannot always handle that. Okay, so keep that is in the mind. And also parts can waste the resource or terminate very frequent. Let's say like there is a spike for coming for 2 minutes due to some system services on your node. There is some other services running and that is unexpectedly consuming a CPU or memory, and indirectly it's consuming your parts. When this happens, you should always if you are not specified CPU limit or request or memory CPU request or limits, that may happen inefficiently. Okay, so always it best to define the request and limit for all your parts. Okay, and the next thing is like your cluster is running out of capacity, will not able to HPA cannot do. Let's say like your node is already filled with the memory and you have given HPA with the memory based, and you've given like a 10 or 20 pods. Already there is a 5 pod is running. When there is another 5 pod as scheduled, automatically it will be in a pending state. Your application will be again stuck. If there is high memory utilization keep on increasing, your pods will be killed with OEM killed. Okay. So in that case, what you have to do, you have to use HPA along with the CA, it's a cluster autoscaler, then it will be useful. Okay. We're going to discuss later, not today, but in a future video, we're going to discuss about cluster autoscaler and how we can combine both the autoscalers. We'll see in that. And it doesn't support daemon set, obviously it won't support, or there is no use case much, I can see it. So that's one thing you should understand, you should keep it in the mind. And don't conflict with your VPA like a virtual autoscaler with HPA. Okay, either use one or you have to very tightly you have to design this conflict, HPA and VPA together. Okay. And another drawback I can say, like HPA doesn't take network or storage capacity into the account. Like it won't calculate the much capacity of the network or storage capacities. It can track the latency, but not beyond that. Okay, so there is some limitations. So you should understand it. Okay. And best practices, they should be always important. Again, why? Because the best practices help us to define whatever we are want, right? So always use your pod distribution budgets if you are running a mission critical applications, and that will help you to keep your application always up and running, and also it help you to avoid the autoscaler to scale down unnecessary replicas. Okay, and always keep the resource request close to your average. You should understand your application, how much average it requires and how much it consumes, or you have to plan accordingly. So you should calculate that and you should give your HPA count. If you blindly give some random numbers, sometimes it may not help. Maybe your application already data and HPA isn't aware of it, or your application is continuously spikes up and spikes down. Okay. And increase the CPU request for slow starting application, because it's maybe initial time whenever like some Java Spring applications, when it's starting, it always consumes high number of CPUs. Okay, so those kind of applications you should always give the high CPU limit, otherwise HPA thinks there is something bad and it start doing auto scaling, so that we can avoid such things. Again, don't mix your HPA with VPA. So that is one best thing. Okay. And create HPA always using a YAML. Okay. So you can even use a command line, but it's not difficult when you want to handle through version control, or let's say like you are moving to the GitHub's model, and on that time it'll be so tough for you. Okay. So CLI is okay for practice purpose, but you should not use it with a CLA always. Okay, and production, go with always YAML. So if you are employing a custom matrices, use a correct target type and the pods or objects. Otherwise, it may get confused and your application or the HPA won't work, or there is something will affect that, and you don't get a deserved deserved as a response. Okay, or the result. Okay. So this is on the HPA or horizontal pod autoscaler. Hope this is useful, guys. If you like, please like and share with your friends. Please let us know if you need any other topic to be covered, or if you have any feedback, feel free to share it. That will help us to give the best topics and best solution for your reference in the future. Okay. Thank you. Have a great day. Bye bye.